Assalamualaikum warahmatullahi wabarakatuh. Now we are in manufacturing facilities design subject, and our chapter is a source of information. First thing, most important one is the marketing department. I'm going to tell you there are three main assignment of the marketing department. The first one is the selling price, and then the volume is referred to the how many we can sell, and the third one is the seasonality. But please remember that determining the selling price is not an exclusive function of the marketing, because industrial engineering department actually it can be supplied for the cost data for pricing. The most important one for the marketing department is how they compete in the pricing, because in a market the lower price is the more customers will choose the product. And the pricing, of course, is very complicated because it is integrated many departments, such as marketing, production, and finance department that will take the decision together. And the marketing department also, the most important one task of them is to get information about how many do the customer want to buy. And typically, from the previous research, that we found that 20% of customers buy 80% of total production. It's very interesting, of course, for industrial engineering because it's same with the Pareto chart. And then for the determining takt time, or R, or you can say that is the plan rate, is determined by the amount of operating time and the amount of product required during the period. So it will I will give you the example. For example, if the schedule call for the production of 1,000 of mobile phone, for example, for the mobile phone, the production call 1,000 mobile phone per day or per shift. Then at the end of the production period, the company must have 1,000 mobile phone completed, packed, and ready for the shipment. So to meet the schedule, essentially the plan, we have to must produce enough part and component per period to keep up the production demand to achieve the target of the plant. So we have to ensure that the takt time of the plan rate of the product will be running well. And the equation of takt time, it is the total daily operating time divided by the total daily production requirement. And then there is some information needed to calculate the takt time. The first information that we have to know the production goal, and then the amount of time allotted for the production of the unit. For example, maybe you have a 1 10-hour shift, or 2 8-hour shift, or 1 8-hour shift, and other scenario. And then any non-productive time that is taken away from the production, such as a break time for praying maybe, or for lunch, for talking with other people in a team, to discussion, and so forth. So there is some several information that need to calculate the takt time of or the plan rate in the production. Let's come to the exercise. Here it is the exercise. I have copied to this one and I'm gonna show you. Please give me a minute to finish this work, and then I will tell you how to finish this. Okay, this is how I finished this work. Let's come to the exercise. Assume that the minimax company need to produce 1,000 units of product from the plant. There are only one shift, so it's the information of the allocated time, 8 hours per day, and some allocation. It's any non-productive. The allocation provided each shift are 20 minutes for lunch, 10 minutes for breaks, and 10 minutes for talking in a team, such as a discussion. And assume that the efficiency is at 85%. Actually, we have to find this efficiency number, but please assume in this exercise only that the efficiency was taken from the historical data, and the historical data mentioned that is 85%, but later we will calculate the efficiency, our own efficiency. And then we have the first information is about the 8 hour times minutes, because all of the information other is in a minute, so we have to convert this one to the minutes, so it will get it 480 minutes. And 430 minutes minus 20, 10, and 10 is a count from any non-productive activity, and we will get the real activity operating is 440 minutes. And then 440 minutes times 85%, because assume that efficiency is 85%, and we have the real number is 374. So the takt time, come back to the previous equation. So the takt time is 374 divided by 1000, and we will get 0.374 minute per unit. So we need 0.37574 minutes per unit. In unit per minute, it means that in 1 minute we will produce 2.67 units in 1 minute. The next is just calculating the scrap and rework rates. It's very undesirable, but manufacturing reason to produce scrap or unusable part, though, is undesirable. Furthermore, often there is need to redo an operation simply because the part was not produced within the desired specification, so we have to rework. Scrap and rework result in an efficient and wasteful of the facility's resources, of course. And then how we can say we can calculate the scrap and rework rate. So it will be scrap and rework rates. It will be used for if we want to produce 1,000 product in a good condition, in a qualified product. So how many product if we have a percentage scrap in our production process? Let's come to the exercise. Okay, as the previous, I have copied the exercise here by using the preceding exercise. In one operation, produce 5% scrap. So how many product must be produced if we want 1,000 product, good product desired or produced by our plant? Just give me a minute. Okay, from this, by using the previous equation, I show in the PowerPoint that if we have the 5% scrap, so we have 1,000 good product is the desired product, and we divide it by 1 minus with the percentage scrap. So how many product must be produced if 1,000 good product desired? So we have to produce about 1,052.6, or it can be 1,053 unit. Let's come to another exercise. By still using the preceding exercise, in operation process, 2 other steps are performed. We can say there is a drilling and milling. Now we have 3 scrap produced. There are 5%, 2.5%, and 1%. So how many product must be produced if 1,000 good product desired? From this information, we have 3 scrap that are 5%, it is 2.5, I'm sorry, this is a percent, and also this one is 1%. So how to finish it? Let's check this one. Okay, that is, if you have 3 scrap, 5%, 2.5%, and 1%. So this is the way how to solve this problem. So we have to divide with 1 minus 0.05 is mean the 5% times 1 minus 2.5%, and times 1 minus 1%, and we will have this one is 1090,5, or we can say that is 1091 unit have to be produced if we want to if we desire there is 1,000 good product. Come to product design department. Actually, there are 4 main points of the product design department. And the first one is the blueprints. The second one is the bill of materials, indented bill of material actually, and there is the assembly drawings and model shop samples. We start from the blueprints. The blueprint also is used to communicate the idea of what a company want to produce. It's very important. All that is very important because it is a sample inform the facility designer of the prime mission. It will give a detailed description of what needs to be accomplished. And blueprint, or we can write also as a sketch, pictures, and CAD as a computer aided design, drawing, and other form. You need to drawing. What is the simple blueprint of part drawing, sample blueprint, and also the sketch of your product. And also don't forget you need to make the part list. The part list is also important for you because the designer will need this one, because we have to know what part have to be produced and how many quantities, because it also will be correlated with the decision you have to fabricate it or we're gonna buy. Your drawing also can be exploded drawing because it's very useful to know each part, the detailed part of your product. And then the bill of materials. It is the example of the bill of materials. You can give the name of the company. I mentioned that it's a Minimax company example. And then product prepared by date. And the most important, you have to write the level of your part, and also give the decision you want to make or buy. So bill of material present the hierarchical structure of the product by identifying assembly, subassembly, and required subordinate part of each assembly or subassembly. If you see that in level O, is the level O mentioned that it is the final and the finished product. The number 0, the top of the list, which is the finished assembly product. And then under this list the major assembly, and each is assigned as level 1, final assembly before the finished product. And under this, so that will be the sub-assembly in the third, and the sub-assembly and the minor assembly in the level 3. So please fulfill all of the material in this form. Right, your level, your part number, your part name, drawing number, quantity per unit, and decision make or buy. And also please give the assembly drawing. Assembly drawing is used to inform the minor of each assembly. This is the example only. Actually, the exterior body assembly is not a finished product, and A1 here is the assembly, is the level 1. The level O is under this one is the next process by joining the A1, A2, and A3. So it is only the example for how to draw the assembly chart. So you can use this one as a part. In the left is the part number of part, and the second one is in the level 2. In the level 3 is the sub-assembly, level 2 is the sub-assembly, and level 1 is the assembly, which is the exterior body assembly. And then the model shop samples, or we can say there is a prototype. Usually it's handmade and very costly, but however it can illustrate the exact model of what kind of product wants to be produced. So it is costly. Of course they are not always be available, but if they were, they will be very helpful. So the designer will know the feel of part, take them apart and reassembly, look at each part and consider how to make the part. So it's very specific. Will be there a systematic disassembly of a prototype. It will be helpful to give the comparison product that will be produced with our competitor. So if you want to make the model shot sample or the prototype, please unpack the unit, play with the finished product to see how it functions. So because the good understanding of the finished unit is very helpful. And then please disassemble the product, look at each part, and please give this a decision. You want to make it or buy, because if you buy out all of, maybe because it's very cheaper, so maybe you will be called as an assembly plan, not manufacturing plan. And it is the make or buy decision how we decide we want to make or we want to buy our part. Actually, the decision normally is straightforward and it's easy. If we are an existing company with a product line, we can see and we know that where the part can and where cannot make. So what part we can make and what part we cannot make, it's very easy if we have familiar with our line of production. So what have to be considered, I have been summarized some important things to be considered. The first one is to know the company can and cannot make. So please understand your line of production first, and then buy all parts and become an assembly plan. And if you not want to be the manufacturing plan, only assembly plan, you can buy out all parts. Check the takt time. If you can make it fabricated faster than the supplier, so please fabricate it. Check the cost. If you can make it cheapest, because the cheapest always is the best. And then check the space availability, because if you need a department for fabrication and other space, it will be costly. You need the space and also you need a cost to enlarge your space. And the last one is about the feasibility studies. All new project ideas need to be evaluated before they are accepted as new manufacturing facilities project, a design project. It's very important because is one of method to determine decide whether the project idea is workable or not, because sometimes we have the brilliant idea but it's not workable on our production plan, and it will be very difficult, such as handcraft is very difficult. A feasibility study generally performed by the highest level project manager and engineers that have been experienced and have many experience to analyze the product that can be produced in their manufacturing or not. So it back to the what can and what cannot be produced. For example, in a several product, maybe it will be four product or 5 product proposed, 4 or 5 new project ideas proposed, but only one project was approved. Why? Because the other one is not feasible. It's a function of feasible studies to give you analysis in the early. Okay, that's all I think. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.